So, power in AC electrical systems, section 2.3, and this is the first part of a sequence about power in AC electrical systems. Most probably there would be two sections, another under 2.4. In this section we are going to basically discuss about the difference between DC power and AC power. So especially when it comes to AC power, there are three components: current power, active power, and reactive power. And in addition, we would like to discuss about power factor. So these things are very important both as a student and once you get into the industry. You will come across situations where this knowledge is highly valuable. For an instance, if you're going to site a conductor, in such situations you would need to know what is the apparent power of that load which you are going to wire through the conductor you are going to use. And for an instance, let's say you have a load and you have a generator, and if you're going to wire this load and generator, you need to know the current capacity of the wire. So in such situations you need to take account the apparent power of the system, so in order to calculate the current values. And in the same way, there are situations where you would like to know the reactive power component, or as the active power component consumed by or as delivered by a device or a load. So there would be situations where you have to argue which power is more important and which power is not important, etc. So the hope of this section is to give you an idea about these components, to teach you the basics, and we will go through the examples. And before going into the section, you need to know a few things you should have covered from the previous section and from the previous knowledge about electrical engineering. For an instance, it's very important that you get to know your electricity network theory knowledge. You have to review it from time to time. It's going to be useful, especially in this section, and especially into section 2.2, the previous section of this series. It was very helpful to find the current and voltage components through different elements in AC circuits. So for AC electrical analysis, it's very important, and you should have an idea, not an idea actually, you should know what it is meant by power in DC systems. It's really important that just not stick to the equation P equals VI. So you should have a better idea about what it is meant by the power. So that it is the relationship between the potential difference and the rate of change of charge. So those things I believe you already know. And in fact, the knowledge on sinusoidal wave representation, it's coming under trigonometry, is again going to be important. And so you should have an idea about what is phase, what is initial phase, and amplitude was RMS value, what is the difference, what is the equations, and frequency was periodic times. Those things you must know. And in addition, it's better to know about the complex numbers, but if you're not that good in complex numbers, don't worry, because we are going to use the scientific calculator. So in that case, I hope it won't be that much of a problem. But still, if you know the things, if you know the theory, it would be very easy for you to understand this section. Therefore, I highly recommend you to go through the complex number theory, which you learned in under maths course. And electricity basics, of course, you have learned from the first year. So I hope there won't be any problem with the knowledge in the basics of the electricity and electric circuit analysis. The previous section, you must, very importantly, you must cover this section. So it's very important that you know the electric circuit analysis. In addition, I highly recommend you to go through class note 3 and 4 it's better if you go through them. You can have some idea about what we are going to talk here. And at the end of this section, after going through these problems I have given here, you should be able to understand the theory behind apparent power, active power, and reactive power, which means you should be able to apply that knowledge to calculate the apparent power, active power, and reactive power for a given component. When the necessary details are given, you should be able to pick up the necessary details. So let's say some details like voltage, currents, and some other parameters are given to you related to electrical circuit or an element. You should be able to pick the correct values, the needed values, and calculate the required, whatever the given or else asked components. And you should be able to argue whenever you are going to, let's say, like I said earlier, you're going to size a conductor. So you're going to find the current carrying capacity of a conductor needed to wire a load to a generator. So in such situations, you should be able to argue which power component you are going to go with. Is it the active power, reactive power, or apparent power? Or else you are going to integrate several loads into the same system, electrical system. So in such situations, which power components are important and which are not important, you should be able to argue and understand. And at the end, I'm going to kind of introduce you the concept of power factor and the use of it, and how the apparent power, active power, and reactive power are related with the power factor. So those things you should be able to at the end maybe interpret the idea of power factor to someone else, and of course you should be able to calculate it by using the theories. Right, so let's go one by one.